Wheel Pump, soluciones que fluyen.
In an oil and gas facility, fluid systems are subjected to many changes in flow and pressure. Such changes initiate varying degrees of pressure waves, also known as surge or transients. In particular, these pressure transients can happen during the loading and offloading of fuels between tank farms and loading ships. Fuel dock delivery systems are especially exposed to unforeseen events that cause overpressurization, pipe ruptures, and numerous other system failures. It is quite common for surge events to begin with a low-pressure transient due to malfunctioning equipment, pump failure, or loss of power during the fuel transfer operation. In a low-pressure surge event, vapor pockets can quickly form as the pressure wave is emitted out. The speed of the moving pressure wave is a function of elasticity of the fluid and pipe, often exceeding 4,000 feet per second. When a low-pressure transient wave reaches the end of the system, it is reflected backwards with enough energy to collapse any vapor pockets that have formed. Sudden collapsed vapor cavities release a burst of energy in the system and cause new extreme high-pressure transient waves. With nowhere to go, the energy wave is emitted throughout the system, hammering all junctions along its path. The sudden pressure spike is enough to cause catastrophic failure at the pump or weak points within the piping system, such as elbows and various instrumentation. Using computer surge modeling, such as applied flow technology impulse software, transient pressures and vapor volumes are predicted. Surge models show a growing vapor cavity as the pressure drops below the fluid's vapor pressure and into full vacuum. When the transient wave returns to the vapor pocket, the pocket collapses, leading to immediate pressure spikes and secondary surge events. Blacoh Surge vessels and surge wave monitoring systems are effective and innovative solutions when mitigating risk and protecting fluid transfer systems. When Blacoh Surge vessels are installed near the pump discharge and there is a pump trip, fluid is released from the vessel. The added fluid prevents the system from dropping below vapor pressure. The fluid energy caused by the returning high-pressure transient is absorbed by the vessel. The internal bladder oscillates, dampening and stabilizing the fluid pressure, protecting the system from potentially catastrophic negative vacuum conditions. Because transient pressure waves are moving near the speed of sound, monitoring surge pressures requires a high-frequency pressure detection device, also known as transient monitoring. Blacoh's surge wave transient monitoring systems can detect and record pressures at 100 Hz or higher, allowing critical systems such as loading terminals to have early detection and prevention of pressure problems. Transient pressure monitors enable plant operators to be aware of the true system pressures and fluctuations normal pressure detection equipment cannot provide. Blacoh surge wave equipment also enables engineers and end users a method for validating the computer surge model. Early pressure transient monitoring, along with Blacoh surge vessels, provide fluid system operators with optimum solutions in preventing catastrophic failures and protecting critical systems. Valve closures present large safety concerns as they emit immediate high-pressure transients, especially when a valve is closed abruptly. System design engineers must think about all valves in the system, including valves on the ship which are outside the control of the plant operators. Should a ship break away from the dock, engineers must decide how quickly the valve should close. A 30-second slow closing valve may decrease the initial surge in pressure, however thousands of gallons of fuel would be discharged to the environment. A quick 2-second valve closure greatly minimizes the spill. However, the immediate upsurge in pressure can easily exceed design pressures. The high-pressure transient wave initiated at the valve inlet travels backwards towards the pump at a speed near sonic velocity. This sudden overpressurization can result in catastrophic system failures within the piping, fuel systems, and equipment. Such failures are often the initial cause of much larger and more costly safety events. System designers are careful to incorporate within the surge model the geometry and closing characteristics of the valves. This is necessary in order to discern in advance the true potential transient pressures. Solutions for mitigating high-pressure transients might encompass specific valve operations, relief valve skids, and/or surge vessels. The Blacoh Surge vessels have been engineered to immediately give and receive energy as needed. Blacoh Surge vessels are always on, dynamically reacting to surge events throughout the fluid system, protecting equipment and providing superior containment with no loss of fluids. Surge modeling enables engineers to consider numerous operating scenarios and properly analyze risk that would otherwise be hidden. Blacoh Surge vessels, surge modeling experience, and surge wave transient monitoring systems mitigate risk, prevent fluid system failures, and protect equipment. Owners and operators gain confidence in the system design where safety and environmental management are critical to the success of the plant.
Wheel Pump. Soluciones que fluyen.